Hello everyone, I'm Zaineb Sakhrawi, PhD student at the Faculty of Economic Science and Management of Sfax University. I'm honored to have the opportunity to share with you today our research paper entitled Investigating the Impact of Functional Size Measurement on Predicting Software Enhancement Effor using Correlation-Based Feature Selection Algorithm and Separate Vector Regression Method. This research paper is realized by me, Zaineb Sakhrawi, Dr. Asma, Sellami, and Dr. Nadia Bouassida. So let's start by the context. First, let's be clear about what software enhancement maintenance is for. One of the most challenging problems in managing software project is how to obtain an accurate estimate when requirements are likely to change. Change requests or modification requests as represented by the ASO are classified into type: correction software maintenance and enhancement software maintenance. In our work, we will investigate the enhancement software maintenance, which is defined as a modification of an existing software product to satisfy new requirements. We have two types of enhancement software maintenance: adaptive maintenance, that provide enhancement necessary to accommodate changes in the environment in which software product must operate, and perfective maintenance provides enhancement for improvement of program documentation and improvement of software performance, maintainability, or other software attribute. I have divided my presentation in 4 sections. We have first, I would like to begin with presenting current challenge and explaining our objective. After that, I will explain our approach based on the use of correlation-based feature selection algorithm and separate vector regression methods. Then I will move on to talk about the discussion and comparison. Finally, I will end with conclusion and some perspectives. So let's start by the problematic. Software effort estimation can be considered as a subdomain of many software activity, including the prediction of software development effort, testing effort, maintenance effort, etc. Generally, there are many methods used for estimating effort, divided in 3 categories: expert judgments, algorithmic models, and non-algorithmic models. Anybody can use these models for estimating future projects. A review of various machine learning techniques revealed that the accuracy of estimate can be achieved. So, despite the large number of proposals interested in finding accurate estimates, there is no clear evidence in determining which model is the best for estimating enhancement effort. So in practice, the estimate can vary when the inputs vary. The inputs include the size of the product requirements and cost driver. In our work, we will investigate the impact of software size for estimating or predicting software enhancement. Software size is widely recognized as a predominant cost driver for the effort and cost needed for software projects. In this work, we assess the effectiveness of the most popular functional size measurement method, the first generation, the International Functional Points User Group, and the second generation, the Cosmic Common Software Measurement International Custom. So, this for measuring functional change, and therefore to be used as independent variable for predicting software enhancement effort. The prediction here is carried out differently by applying the correlation-based feature selection algorithm and separate vector regression using the dataset repository, the ISBSG, the International Software Benchmarking Standard Group. This for training and testing the models. I will explain our approach in this slide. This slide presents our research methodology, setting up 2 regression-based models, one using the Cosmic as independent variable and the other, the IFBUG, as independent variable. And making comparison between their prediction accuracy to identify whether the cosmic method provides useful information, means more accurate functional change size than IFPUG for predicting software enhancement effort, using a training dataset to be used subsequently to predict the total enhancement effort for the development of software project in man-hour. In our work, we have used the ISBSG dataset, which is widely used for software project estimation. It maintains a repository of data about completed software projects, including new software, enhanced software, and redeveloped software. So I will begin by the first model, or explaining the first model. We have here, we select the data regarding enhancement as independent variable, as development type, and the count approach is the cosmic, and we have selected, we consider only data with soundness and high quality of integrity, having data quality rates A, B. After the pre-proceeding phase, we have selected a total 16 attributes feature for cosmic data, and after project selection with high quality of data, means after the pre-proceeding phase, we propose to use the correlation based feature selection algorithm for selecting the features that are relevant for the software enhancement effort prediction. That is, after applying the correlation-based feature selection algorithm, we determine which features globally and consistently appear in the optimal set of features. In this step, the filtering is done using the Pearson correlation coefficient algorithm, which is the most commonly used algorithms. Pearson correlation coefficient is a single number that measures both the strength and direction of the linear relationship between two continuous variables. Value can range from -1 to +1, where 0 is no correlation, 1 is total positive correlation, and -1 is total negative correlation. In our case, we will plot the Pearson correlation heat map. The use of Pearson correlation algorithm provide a list of features that are sorted based on their degree of correlation to the model class, mean the normalized work effort, the enhanced work effort. And in our case, only feature having correlation larger than 0.4 are selected with the output variable. So, showing the selected, we have this table show the selected feature with their corresponding correlation coefficient value having score larger than 0.4, computed using cosmic dataset between functional change size, functional change, and the enhancement effort, the normalized work effort. Therefore, we have from the result, the correlation coefficient value have a value of 0.5, which is a moderate or acceptable correlation of functional change size with enhancement effort compared with other features such as change work effort and unrecorded work effort. Therefore, functional change size is chosen as a primary independent variable. So, to try and test the dataset, we have select the supervector regression models, which is the most used machine learning technique for enhancement or for estimating enhancement effort, using the correlation-based feature selection or the especially Pearson coefficient algorithm, and with the supervector regression method can lead to more accurate enhancement effort prediction when the functional change size is used as the independent variable. with the minimum of mean absolute error 0.03 and root mean absolute square error 0.10. So, moving to the second model, we selected the data regarding enhancement as the development type, where count approaches the IFBUG method. We consider only data with soundnesses and high level of integrity, having data quality rating of A or B. After the pre-proceeding phase, we have selected 12 feature attributes for the IFBUG data. So after the pre-processing phase, we propose to use the correlation-based feature selection algorithm for selecting the features that are relevant for the software enhancement Effor prediction. That is, after applying this algorithm, we determine which feature globally and consistently appear in the optimal set of features when using the IFBUG method for measuring. So we have plotted the Pearson correlation heat map. Result: only feature having correlation larger than 0.4 taken into account absolute value are selected with the output variable. For the IFBUG dataset, the use of correlation-based feature the correlation-based feature selection algorithm selects 4 out of 12 of feature. When using data from dataset, when using data from the ISBSG data, the correlation coefficient between functional change size and enhancement effort has a value of 0.1, which is very weak. That indicate a very weak correlation of functional change size with enhancement effort when compared to the other features such as the Effor build and the Effor test summary work effort. Results show that choosing functional change size generated from the IFBUG sizing as primary and dependent variable may not provide an accurate estimate enhancement effort prediction. On the other hand, a careful inspection of the feature list produced by the Pearson correlation algorithm as shown here indicate that the effort test, effort build, summary work effort, and normalized work effort level 1 were the most meaningful features that helped in prediction effort. As the same step for the first model, we have used the support vector regression for timing and testing. The selected feature selected by the correlation by the Pearson correlation and support vector regression methods can lead to accurate enhancement effort prediction with the minimum of mean absolute error with 0.03 and mean root mean square error value that has value 0.1950. So moving to the discussion and comparison, the main reason behind selecting functional change as independent variable in our study is that software functional size is correlated to a software project effort, and sensitivity to changes in functional change has a greater impact on the project effort. So we have four discussion or 4 findings. First, the use of a price measurement of the cosmic functional change provides significantly better result than the IFBUG for predicting enhancement effort. Second, the cosmic functional size measurement method is evaluated to be the most effective when compared to the IFBUG functional point analysis method. It is evident from the results with the minimum mean absolute error of 0.0392 and accurate predictions have a value of 98%. Third, In order to identify the effective determinants for enhancement effort estimation, the importance of each feature using cosmic and IFBG is computed using the correlation-based feature selection algorithm. The use of the correlation-based feature algorithm results show the importance of functional change size feature using the cosmic functional size measurement method. So, moving to the conclusion and perspective. So in our study, we have investigated the problem of accurately estimated effort for software enhancement projects with the two functional size method, the first generation, the IFBG enhancement size, and with the second generation, the cosmic enhancement, the cosmic functional size. So the first, the correlation score between the IFBG enhancement size and enhancement effort presented by normalized work effort in the ISBG dataset has a value of 0.1, which denotes a very weak correlation. Therefore, choosing the IFBG as the primary independent variable cannot give an accurate estimate enhancement effort prediction. However, the estimate effort that results from the supervector regression method provides a good accuracy. The correlation between between cosmic enhancement size and enhancement effort has a value of 0.5, which denotes a good correlation as compared to the IFBG. Therefore, choosing the cosmic as independent variable or using cosmic as a primary independent variable provide an accurate estimate effort prediction. The estimated effort that result from supervector regression method provide a good accuracy. So cosmic here can be considered as effective measurement method for size and enhancement, and therefore thereafter predicting its corresponding effort. So to conclude, we have using supervector correlation-based feature selection algorithm and supervector method. The experimental results suggested that the cosmic sizing is significantly better than the IFBG when used as primary independent variable for predicting enhancement effort. Having the results show small mean absolute error with 0.0382 and with quite good performance has a value of 98%. So for future work, several extensions can be made. Only one real-world dataset, the ISBSG, is used for experiments in our study because it is the only one that uses cosmic functional size measurement for enhancement projects. This work will be extended by exploring the accuracy of enhancement effort using boosting machine learning techniques such as gradient boosting regression and other feature selection algorithm. So finally, thank you for your time and attention. Stay safe and have a great day. If you have any question or comment, you are welcome.